Okay, so guys, welcome back. So let's begin the routing now. So like I said, I'm just assuming this the area I want to cover, more of like the floor plan. This area covered by this white box. So you can do any method anyhow that suits. So for for me, I would like my power rail to be at the top and at the bottom. So power rail, that is the positive supply and the negative supply. More of like trying to follow this orientation: positive supply, negative supply. Then the devices are in between. So that's kind of what I want to do. Again, there are different rationales for for that specific um, circuit. So at being this was not as long as this, then things would have been fine. But because this is so long, I would like to make it horizontal. So that's just the choice I want to make. Hopefully it does not turn to be a bad choice, but then it's a progressive thing. If you think that would not be the optimum way to make use of the area, then you just readjust. So I want to make this horizontal, so I'll just make select I, then I'll just come here, edit, and I think rotate 90 degrees. So it's been rotated, so it's still selected. Then it's the PMOS, right? I want to move it to the top, so it's at the top now. So let me rearrange this, then move it down. Okay, I think I like something like this. Yeah, I think something like this is fine, but let me just adjust this a little, then let me centralize this a little. Okay, so that's fine. I think for it, just to let you guys know, for instance, let's say I brought this nearer, even if it's not touching. Let me see, bring it down here like this. Okay. Okay, yeah, let's just bring things back down. Okay, so these are fine. So like I said, my power rail will be up here, the positive power rail, and the negative power rail will be down. So this is the NMOS, this is the PMOS. Then the power rail will just basically be a metal contact. It will be a metal contact. So I like metal one. So metal one, the first level of metal layer. So I'm just going to be making the power rail like metal one. Power rail is just the contact where when you fabricated the NMOS, you interface the inverter. I mean the inverter, not the NMOS. You interface the inverter with the outside world. So that's what we're going to do. So NMOS, the M metal one, so it will be up and down. So let me make the area where I want to make the metal one. So I'm trying to arrange the box, so I want it to get up to this point. So I position my cursor, then right click. Let me still make it a little bit. Okay, so I'm ready. So all I just need to do, I'll just come to the command console and say paint metal one. For those using mouse, just come here, metal one, and press the middle mouse button, then the metal will get painted here. So but I'm not with the mouse right now, so I'm using the command. So paint metal one, so enter. So now the metal one is here. So I'll do the same for the negative supply rail down here. So but let me move this guy is away, so I select let me select so let me move them away. So S for select, then move, select, move, select, M for move, select, M for move. So I want to make room down, then this same box size, so I want to repeat the same box size. So all I just do is I'll try to draw the box over that area so it's the same size, right? Then I'll just move it down. Okay, let me just increase it. Okay, so it's kind of aligning now. So then I'll do the same thing, paint metal 1, so it's painted. I'm also, as I'm doing the painting, as I'm beginning the routing, as I'm doing the routing, I'm also checking the DRC error if there's any, so just updating myself. So next thing now, it's now this is the PMOS. Let me zoom in a little. Okay, so this is the PMOS, right? Let me see if I can still zoom in. Okay, zoom in. Yeah. Zoom in. To zoom in is just Z. Then to zoom out is Shift Z. So this is the PMOS. So this you use the diffusion so to know. So the diffusion is brown. So this is the source, the drain. Again, you can interchange it. They can be interchanged. You could call this the drain, this is the source, but for easy routing, coming from the schematics, we know the terminal closer to the power to be source. So let's just follow that. Let's just be consistent so that it will be easier. The picture of the routing would be clearer, would be better. So but it's just good for you to know that it doesn't matter whether this drain or source, it just doesn't matter. So but let's just follow the pattern. So that means we'll be taking this to be our source and this to be our drain. Since this is a positive power supply, the source of the PMOS should be closer to power supply than its drain. Then for the NMOS, this is the NMOS. I am not, this is the source, this is the diffusion, right? And this is the gate length. So you can take this to be the drain and this is the source. So that is when I'm routing the NMOS, I can make this the source, the drain, then this the source. So let's just bear that in mind. So source, the drain for the NMOS, for the PMOS, then the drain. So since this is the drain, that's what will be connecting to the source of the PMOS. The drain of the NMOS will be connected to the drain of the PMOS. The drain of the NMOS will be connected. So this is already the source of the PMOS. This is the drain. So if this is the drain of the NMOS, that is, we'll be routing it to this point. And if this is the source of the NMOS, that means it will be connected to the negative power supply, which is what we've provided here. So let's now start the routing. So maybe let's start with the routing of this. So again, like I said, I like the metal 1, so I'm just starting with the metal 1. So I'm going to do a routing. I just need to connect a wire from here, the drain, to this point. So please, this is where it gets tricky. So let's focus. So I this my attempt in trying to make the wiring. So I would want to paint this place metal 1, that's blue, but no, I can't do that. Why? If you notice, there are blue areas here, right? Blue areas here, and there's a blue area here. Okay, fine. Why we want to connect this point to this point? Okay, but at the same time, because there's a blue area also here, it means if you'll be painting this wire blue, that is metal 1 also, that is that there'll be a connection not only between here and here. This points too would also be connected here, and we don't want it. That's this point here, this blue wire here, it's correspond to, I called it the guard ring, but it corresponds to the contact for the substrate. So okay, so for the substrate, right? So okay, maybe it's a good thing the substrate for the PMOS, yeah, should also be connected to the power and should be connected to the source. Okay, maybe we're lucky for that, but it's not all the time we want to do that. Get? So I would explain what would have done for alternative situations. So what am I trying to say? When layers of the same type come together, bear that in mind that they would be connected together, and sometimes we may not want them to actually be connected. So for us to, if we don't want that in such situation, I'll let us know what we're going to do. But for this situation, we seem to be fine with it, because this guard ring corresponds to the contact for the substrate of the PMOS, and it's a thing we desire for the PMOS, to connect the substrate to along with the source of the PMOS, then to the power. So we can just go ahead and do the connection. So let me zoom in again, and I would then do paint metal 1. So now it's painted. So now I've connected the source to the positive power, and I've connected the body of the PMOS to the positive power, because it's desired. Look at what I'm saying. Look at the body, it's also connected to the positive power. So that's good. So next, let's see. So now let's connect the drain. So the drain of the PMOS should connect to the drain of the NMOS. So we're taking this point to be the drain of the NMOS. So there'll be a routing from you may want to continue from here because symmetry matters, but it just means you can connect from any point along this contact to this point. Right, so let's do that. Okay, and by the way, let's also take note, we don't want the wiring to be too much, like the dimension. Okay, if a wire is too long, its resistance increases and all, but many times you can't help it. So but I think the area we've chosen, it's small. That's why I've brought this nearer, so that the length from here to here would not be too much. Okay, so I'm just going to, since each box is just, I think, 1 micrometer, so 1 micrometer is really too big, so let me not make it twice. I should just make the width just smaller 1, or should I reduce this to just 0.5? so okay, no, okay, it's fine. So from here, But now we have a problem. This is still the guard ring, and that serves as a contact for the bulb, right? So as contact for the bulb. So if we pass metal 1 from here through to this point, that means unintentionally the drain of the source, of the PMOS will be connected with the body, and that's not what we desire. So the drain is just the source that is connected to the body, not the drain. So that means what we need to do is to avoid, since we want to use metal 1 to do the connection, to avoid that unintentional connection at this point, we can interchange. We can use a different metal layer. So instead, I'm going to change to metal 2, so that when when the metal layer is crossing this point, they will not be connected, because they are different layers. You get, remember, when layers of the same type crosses one another, overlaps, yes, the usual assumption is that they would connect, they will short to one another. So since I don't want a short, if I use the metal 1 here, it's the body would also be connected to the drain, so I don't want that. So instead I will use metal 2. So even if it's crossing from here down here, they will not be connected. But what does it also mean? It also means that since this is metal 1, I want to start with metal 2 from here. It means this point I actually wanted to connect down to the drain of the PMOS would also not be connected. So that's where vias come in. Remember, I talked about via. So I talked about via 1, via 2. So you can see them here, via 4, via 3. You still can't find the via 1, but it's not a problem. We'll use the command console. So that's where via comes in. So via 1 would help you connect metal 1 and metal 2 together. You get. So I can go ahead and connect metal 2. So I'll do paint So but in advance I would like, okay, so this I would like to connect it. So let's do it this way. Okay, so paint metal 2. So the purple kind of layer comes up, but I want to, this is the point I want to connect, right? The drain of this, I want to connect it. So let me continue the connection. I want to connect it to the source. So I would continue again, paint metal 2 so that it will continue to this point, like to continue to this point. But let me just do something. So but we know that this is where we want to connect, right? And originally this point, that's this drain of the PMOS, it's connected with metal 1. So it means the metal 1 and the metal 2 would actually not short, but we actually want that metal 1 to be connected. So that's where the via comes in. So I'm going to create a pad for the via. So the pad, just you create a pad by just making a box. So this pad here, this pad here, I would fill it with the via 1. So I'll do paint via 1. So via 1 is painted. So that way it means this point, this metal 1 layer and this metal 2 now is connected. but because there's no via here, it means this metal 1 and this metal 2 are not connected. So that's definitely what we want, so that's fine. So but now we can see DRC error already everywhere, so we don't know why. So let's place a box around the area, then let's ask DRC why. So the reason is that metal 1 overlap of via 1 is less than 0.06 micrometer in one direction. So what it's trying to say is that look at, you can see I intentionally made the pad of the via 1 this way, that is, I made it smaller than that metal 2 contact intentionally. So that's so because an overlap is needed, so that way the metal 2 overlaps the via, you get, it's just like a junction point, you get. So now it's complaining that metal 1 is not doing the same thing as metal 2 is doing. So that is, the metal 1 area is, which is this point, right, this point, this whole point, this on this drain part, it's too small. So what I need to do is that I can just increase it. I can increase it to you know, as kind of big as the metal 2, so that it will correspondingly overlap, just like how the metal 2 is overlapping the drain, the via 1. So I will now come and say enter the command paint metal 1, paint metal 1. Okay, so it's painted already, but then there's one more error to go. So I think that one was solved, but it's in trying to solve that, another error was generated. So let's ask DRC why. Say the spacing between the metal, so between, you know, now I've painted metal 1, 2 all over. So now this metal 1 and that metal 1 I just painted, the spacing is less than 0.23. So guys, you can see, you're welcome. It's how, you know, it can be with laying, a lot of things to take note of, a lot of parameters. So what do? It means we have to increase the spacing. So in order to do that, I would adjust, these vias, I'll take them up so that it will be up to this point, so there will be enough space here. So that's what I'm going to do. So that means I would have to just erase everything I have done here. So I'll tell it to erase via 1. So erase the via 1. Let me start all over again. The via 1 is gone. So also erase the metal 2 also, because everything is messed up. Just erase everything. Metal 2, erase the metal 1 also, everything is messed up. So it's now fine, I've erased everything. So I said I want to adjust them up, so I can just do the adjustments. So it complained of the spacing should be at least 0.23. so, and each box is 0.1, no, 0.05. so this is about half, so 0.05, 0.05. it still look like it may not be, let's say this is 0. So let me still shift it upward, shift it up to this point. So I think this is like 0.05. This looks like still, let's try, let's see. So let me paint metal 1 again. So paint metal 1, let's see if that arrow generates. Okay, good, it's not coming up, so it's all fine. Then I would now go ahead and paint the metal 2. Since we have metal 2 from here down, metal 2 is missing, so I just start the painting from here, so I need metal 2 up to this point. So metal 2, then I'll put the via 1. So again, why we need the via 1, it's so that metal 1 and metal 2 will connect. That's the only way they can be connected. Yeah, and again we are using metal 2 because if we use metal 1, though if you start the connection from here, these points will be connected, but it means this other point too will get connected, and we don't want that. So to avoid it, we just started with metal 2, so the metal 2 will cross this point, you get. But it also means that since metal 2 and metal 1 don't connect directly, it means this point will not be connected, and that's where we want to be connected. So we use the via 1 to make the connection happen. So we are creating this extra square in order to create a pad for the via 1. So, and I think it needs to be at least the square, the pad should be at least, I think, 0.25 by dimension. So that's why. But you don't need to worry if you're not sure. Just go ahead. If the error generates, ask it why, then it will tell you. So then you increase the dimension. Oh no, I'm not supposed to paint via 2, sorry. Erase via 2. I'm not supposed to paint, so it's via 1 I'm supposed to paint. Erase via 2. Erase via 2. Then it's affected everything is messed up again. So let me paint back metal 2. Everything is back. Then so paint via 1, not via 2. So via 1. So successfully painted, no error. So now I can now move away, so that part has been connected. So let's now continue the routing down to the, we want to connect the drain here to this drain of the NMOS here. So let's continue the routing. Okay, so let me make it as long. It's left to you. Just can apply creativity while also observing the rules. Yes, you're all free to just do so. Let's continue painting metal 2. So metal 2 painted. So here now, so I now want to connect this to this point now, the drain. So I will continue with using metal 2 to connect this point. Why? Because I want to connect this point to this point, right? If I use metal 1, this is not the point I want to be connected, so this point will definitely be connected to also this point, and that's not good. Because why? This is the body of this is the connection for this is the contact for the body of the NMOS, and the body of the NMOS should be connected to the source of the NMOS, not to the drain. So I'm going to continue with using metal 2 up to this point. So then I will now I will now connect the metal 1 and the metal 2 together with via 1. So let me continue, then I'll drag this thing up to this point. But let me make a little adjustment. Why do I think there may be issues soon? Okay, let me just do it. So paint metal 2. Okay, it all looks good, but I'm afraid painting metal 1 may cause issues, but let's just try. Let's just try. I'm scared. I'm afraid. Because when I paint metal 1, if I paint metal 1, the spacing would not. So the spacing needs to be 0.2, right? So let me reduce the to 0.1. okay, so the spacing, let's say this 1 2 3, so I need to start from here, then I can, this 1 2, I hope it's up to 3. Okay, maybe I can stop it here. Okay. Okay, let me go ahead and paint, if hopefully no issues. Paint metal 1. Oh, thank goodness, no issues. Then I can go ahead and do the via 2. But let me also paint metal 2 up to this point where metal 1 is. I'm trying to resize the box to fit. So metal 2. Okay, so let me go ahead and paint the via. So let's see, hopefully no issues for the via. I think via needs to be at least 0.23 or so wide, and each box, the dimension is 0.1, I think. 0.1, 0.2, 0.3. It should. Oh no, okay, that's the overlap. Oh no. Okay, let's just do this. Paint via 1. Okay, successfully painted. Okay, so let me zoom out. So now the drain here has been connected to the drain here. So now let's connect the source here to the negative power rail here.